Calculation of capacity of a capacitor. If Q be the charge on one plate and delta V be the PD potential difference between plates, then we have C equals to Q by delta V or Q equals to dV. 1. If the electric field between the plate is uniform, then the equation we can use C equals to Q by dV equals to Q by E dr, where E is the magnitude of electric field and dr is the separation between the plates. 2. If the electric field between the plate is not uniform, then we can use C equals to Q by dV equals to Q by integration of minus E dr. Note, use only modulus value of Q and dV. Capacitance of a parallel plate capacitor. A. When the medium between plate is air. Consider the area of plate is A, charge on facing surface of one plate is Q and surface charge density is sigma. Then sigma equals to Q by A. This implies Q equals to sigma A, equation 1. Electric field between the plate is uniform and E given by E equals to sigma by epsilon naught. Hence potential difference between the plate dV equals to E dr equals to ED, where D is the separation between plate 1 and 2, equal to sigma by epsilon naught into D. Now capacitance C equals to Q by dV equals to sigma A by sigma D by epsilon naught, or C equals to epsilon naught A by D. D. When the medium between the plate is dielectric of dielectric constant epsilon r, hence E equals to sigma by epsilon equals to sigma by epsilon naught into epsilon r. Also dV equals to E dr equals to sigma D by epsilon naught into epsilon r. Q equals to sigma A, hence C equals to Q by dV equals to sigma A by sigma D by epsilon naught into epsilon r equals to epsilon naught into epsilon r into A by D. This implies C equals to epsilon r into epsilon naught A by D equals to epsilon r into C air, or C equals to K into C air, or equals to epsilon A by D, where epsilon is the permittivity of the medium and epsilon r is dielectric constant. Also it is K is epsilon r also dielectric constant. So due to medium between the plate, the capacitance of a capacitor increases and becomes K times capacity in air. This is true for all types of capacitor. Question: two metallic conductor of area A separated by a small distance D is given charge Q1 and Q2 on them. Considering the redistribution of charge, find the capacitance of the system. Solution. The situation is shown in the figure. Charge on outer surface of the conductor equals to Q net by 2 equals to Q1 plus Q2 by 2. Now charge on surface 2 equals to Q1 minus under bracket Q1 plus Q2 by 2 equals to Q1 minus Q2 by 2, and charge on surface 3